Good afternoon. Today I will deliver a lecture on subject Introduction to Microwaves. So, our topic is a Introduction to Microwaves. In this lecture we will cover the introduction about microwave, what are their frequency range and what are application of microwaves, and the performance of vacuum tube at microwaves, and last we will study the microwave amplifier and oscillators. So, first of all, what is microwave? As its name suggests, the microwave microwave are basically electromagnetic wave whose wavelength is very short and its wavelength is in few centimeter to millimeter range. So, generally the frequency range from 1 gigahertz to upward range gigahertz 1000 gigahertz, we call them a microwaves. So, microwave include the entire super high frequency band, that means 3 to 30 megahertz. Microwave, its name suggests the wave that has a short wavelength. So, slide show the electromagnetic wave frequency band. You have already studied these thing in your last semesters. So, entire frequency range can be divided into these bands. Very low frequency range, that are 3 to 30 kilohertz, they are used for long distance communication. Then low frequency 30 to 300 kilohertz, used for marine communication. Then medium wave frequency 300 to 3000 kilohertz, that are used for radio broadcasting. Then high frequency, the frequency range is 3 to 30 megahertz, they are used for long distance communication. Then came a very high frequency, this range start from 30 to 300 megahertz, and this range is basically used for FM radio and television broadcasting. Then is a ultra high frequency 300 to 3000 megahertz for short distance communication. So, basically the next range, that is a super high frequency, then today we will discuss about these, that are a microwaves. That means its frequency range is 3 to 30 gigahertz. Basically it is used for satellite and space communication, radar communication, point to point communication, and extremely high frequency than 30 to 300 gigahertz, they are used for radar and space communication. So, next is the advantage of microwave. Basically the lower band are totally congested. So, lower band are totally congested. So, whenever the new services came into existence, that time the only option is a microwave available. So, there are some advantage of microwaves. So, first one is a large bandwidth. The bandwidth of microwave is larger than low frequency signal. So, due to this large bandwidth, more information can be transmitted using a microwaves. Because of a large bandwidth, more information can be transmitted. Next application is its advantage is a better directive properties. Directivity means ability of a signal, ability of antenna to concentrate the signal into a predefined directions. So, at microwave frequency, it is easier to design and fabricate a high gain antenna as compared to low frequency signals. Generally, when electromagnetic wave emit from a antenna and move from transmitter to receiver, and it spread. Due to spreading of these waves, so most of the signal lost, we call them a free space loss. So, as the frequency increase at a microwave frequency, microwave which has a very high frequency, it is much easier at that frequency to concentrate the waves into a fine beam, so that it can be transmitted from one place to another place. So, basically the beam width is proportional to the wavelength and inversely proportional to the directivity. So, more directivity, the less beam width. So, theta is a beam width, lambda is a wavelength, and d is a directivity, and where c is the velocity of light. So, as a directivity is more, the beam width will reduce. So, as a beam width reduce, so obvious a signal can be shaped into fine beam and can be transmitted from transmitter to receiver with the minimum free space losses. This is because of fact that as the frequency increase, directivity increase and beam width decrease. So, then next advantage is low power requirements. The power required by microwave is very less as compared to the low frequency signal. I have already told you at a microwave frequency it is very easier to design an antenna with high directivity. So, we are using these microwave for point to point communication, that means transmitter is fixed, receiver is fixed. So, energy can be electromagnetic wave can be concentrated in particle direction. So, that is why the free space losses are very less. So, power required by power requirement for transmission of signal is less in case of microwave. Next is fading effect. At lower frequency, the various layer around the earth sometimes cause fading of received signals, because at any receiving point the signal may can reach after follow different distance. As a result, the phase difference may cause fading of signal. Fading means variation of signal strength with times. Sometime when the all the reflected wave and direct wave, ground reflected wave and they came at a different phase. So, sometime amplitude increase, sometime amplitude decrease, but in case of microwave the signal travel in a straight line from transmitter to receiver. So, the amount of fading is minimum in case of microwave. However, this fading effect is very prominent at a low frequency, but in case of microwave the fading is minimized. So, frequency wavelength relation. So, we have already studied in our last semesters. So, this formula C is equal to f lambda. So, basically microwaves is a electromagnetic wave. When it travel into the free space, it has a same effect as a light. So, generally it travel into from transmitter to receiver with the velocity of light. So, C is equal to f lambda, f is frequency and lambda is a wavelength. So, whatever the effect that appear in case of light, that means light wave reflect, light wave refract. Similarly, our electromagnetic wave, that is a microwave, also reflect whenever obstacle appears in their path. Similarly, it also got refracted from a obstacles. So, all the property of the light, the same property also applicable to the microwaves. So, now application of a microwave. So, microwave is used in broadcasting and telecommunication field. So, they are used for point to point communications. So, because of high directional antenna are used for in transmitting the microwaves. So, antenna are very compact and small. So, microwave are widely used in mobile phone networks like GSM. However, the frequency ranges of GSM is little bit lower than that, around 1.8 to 1.9 gigahertz. So, microwave also used in television signal to transmit a signal from remote location to television station from specifically equipped van. So, microwave are also used for communication from one point to another point by satellites. Satellite TV either operate in C band for a traditional large dish fixed satellite service or Ku band for direct broadcast satellites. All these services use a microwave. Now, the next application is a remote sensing. The most important application of the remote sensing is a radar that use transmitter to illuminate an object and receiver to detect its position or velocity. In radar system, a high powers microwave are basically sent into the free space and if any object are present in a space, definitely the wave will reflect from that objects. At receiver end, the frequency may can change due to the Doppler effect. So, that echo can be used to detect their position or velocity of a objects. So, we are using a microwave in radar system for identification of friend and foe. Another class of remote sensing is a radio astronomy. It is a subclass of astronomy that study celestial object at a radio frequencies. So, next application is a heating effect, baking. The heating property of microwave are used uh, for baking, cooking using microwave oven. In microwave oven, food is heated directly by the microwave radiation without heating the container. So, basically when microwave fall over the food objects, so water molecules vibrate, as a result it heat ups. So, the cooking time is very small as compared to conventional heatings. So, then concentrating. So, with the help of microwave we can concentrate the solutions like so permit the concentration of heat sensitive solution slurry at a relatively low temperature. Then we can use the microwave for drying purpose. So, microwave are used for drying the solids. Drying is uniform throughout the product, moisture present in the product is evaporated out, and drying is at a relatively low temperatures. And then enzyme inactivation. The enzyme activation can be achieved by rapid and uniform heating, which can control and terminate the enzyme reactions. So, precooking, microwave are also used for precooking the food item, because there is no overcooking of a surface and cooking losses are negligible. So, that is nutrient in the food are not lost. So, next are parameter of microwave system. So, basically first is frequency characteristics. So, microwave are very short frequency radio wave that has a many of the characteristics of light wave. They travel in line of sight path and can be reflected and focused. Because the microwave can be focused into narrow beams, their energy are concentrated and relatively low transmitting power is required for reliable transmission over a long distance. However, at low frequencies the wave generally spread. So, as a result the free space losses are more, whereas in case of microwave, so they can be focused into a fine beam. So, as a result a low power is signal are required to transmit from one end to another ends. So, next is a system capacity. Obvious bandwidth is more, that means the more information can be transmitted. So, generally microwave communication systems used to carry a telephony, television and data signal. Majority of the system carry multi-channel telephone signal. The individual telephone channel carry 4 kilohertz, while are multiplexed together with the multiplexer equipments to get a baseband signal. So, because microwave has a high bandwidth, and obviously the more number of channel can be transmitted with the help of microwaves. So, microwave frequency, I already mentioned the microwave is a electromagnetic wave that range is obviously from 1 gigahertz to 40 gigahertz. So, basically the band are L band 1 to 2 gigahertz, then S band 2 to 4 gigahertz, then C band 4 to 8 gigahertz, then X band 8 to 12 gigahertz, Ku band 12 to 18 gigahertz, then K band 18 to 26 gigahertz, then Ka band 26.5 to 40 gigahertz, then Km millimeter band, that is a 40 to 300, and above 300 we call them a sub millimeter band. So, these are the microwave band are divided into different frequency are divided into different bands. So, next is classification of microwave on basis of frequency. First is L band. So, L band is a portion of microband of electromagnetic spectrum ranging roughly from 0.9 gigahertz to 1.5 gigahertz. It is used for some communication satellite and bioterrestrial telephone networks. Then S band basically radar short band it is used for microwave band. It is a part of microband that has a frequency range from 1.5 to 5.2 gigahertz. It is used for weather, radar or some communication satellites. Similarly, C band, compromise band, is a portion of electromagnetic spectrum that has a frequency range from 4 to 6 gigahertz. Similarly, another band is X band. Again, the frequency range is 5 to approximately 10.9 gigahertz. It is used by some communication satellite and X band radar. Ku band, so is a portion of electromagnetic spectrum in microwave range of frequency 11 to 18 gigahertz. They are again used for the satellite communications. So, then K band, it is portion of electromagnetic wave spectrum in microwave range of frequency 12 to 40 gigahertz. So, again these are used for radar system and for satellite communication. Then K band, so frequency range above 18 to 40 gigahertz, that are called a K bands. So, these are the various type of bands. Now, introduction to microwave device. A wide range of semiconductor device have been developed for detection purpose, mixing and amplification and attenuation for microwaves. So, microwave tube are preferred over vacuum tube at microwave frequencies. The conventional tube become less effective when used as an amplifier or oscillators. Basically, the microwave frequency are used for transmission of signal from one place to another place. So, when the signal is to be transmitted to a long distance, the power requirement of signal is very much high. Because the power of signal is high, our ordinary transistor can be used for to get a high power, especially device we are using a vacuum tube at high powers, because they can handle high powers, their power rating are very high. So, generally instead of our amplifier, semiconductor amplifier, we prefer the vacuum tubes. So, but generally the ordinary or conventional microwave cannot work over the microwave frequencies because of some effect. I will read it to the next slides. So, microwave tube usually operate on theory of velocity modulation, a concept that avoid the problem encountered in a conventional tubes. Now, electron emissions. In vacuum tubes, basically work on principle of electron emission. The liberation of electron from surface of substance is called a electron emissions. So, in metals, electron in outer orbit are very loosely held by the nucleus. So, when some energy are given to the metals, the outer orbit electron gain energy and move out of the atoms. So, they are free to conduct. So, these loosely attached electron are called free electron and can be easily detached by some external energy. So, a method, next is method of electron emission. So, the liberation of electron is possible only when external energy is supplied to the metals. So, the amount of energy that is required by some atom to liberate electron is called a work function. So, this energy can be supplied by heating the metal, by bombarding some high speed electron on a atoms, or by giving some electric fields. So, electron can be emitted from atom either by heating the metals or by applying injecting some high bombarding the metal with some high moving electrons, or by applying electric fields. So, accordingly there are 4 method of obtaining electron emission from surface of metal. First is thermionic emission. Thermionic emission can be obtained by heating the metal. Secondary emissions. Secondary emissions, that means that can be obtained by bombarding a metal with a high speed electrons. When high speed electron fall over the metal, it will push the outer orbit electron from metal. So, that is called as secondary emissions. Next is a photoelectric emission. The photoelectric emission, the high intensity light is injected over the metals. That photon will give energy to the outer orbit electrons, and the electron will came out of the metals. Then high field emission. By applying high electric field, we can get a electron emissions. So, these are the four electron type of electron emission, but in our vacuum tubes the first one are used thermionic emissions. Thermionic emission. A thermionic emission include heating of a metals. When metal is heated, some of the heat energy is converted into kinetic energy, which accelerate the motion of free electrons. When temperature is raised sufficiently, these electrons require sufficient energy equal to work function of metal. As a result, they overcome the force of nucleus and came out of metal surface. The thermionic emitter that are used in vacuum tubes are oxide coated cathode. They generally have a low work function, 1 electron volt. Its efficiency is high. So, they are made up of a cobalt, iron, nickel or titanium. Similarly, we have a thoriated tungsten. Their work function is 2.6 volt and they are used for high powers. Similarly, tungsten work function is 4.52 electron volt. Its melting point is high, its mechanical strength is high. Because of melting point is high, its mechanical strength is high, its life is long. So, now vacuum tubes. So, electron device in which electron flow through a vacuum is called a vacuum tubes. So, vacuum tube consists of a vacuated glass envelope which contain a cathode, a anode and one more electrode called grids. So, we have a different type of vacuum tubes. One is diode, triode, tetrode and pentode. So, figure show diode and triode. So, this is a symbol of vacuum tubes. Diode means two electrodes, a anode and cathodes. The cathode consists of basically filament and a cathode. Filament will heat up the cathode. When the current DC current flow through this filament, it will heat up the cathode, and cathode is coated with the material that can easily emit electron when it heat up, and for another anode is made positive, obvious electron will move from cathode to anodes. So, second is triode. Its obvious its name is tri means 3 electrodes. It has a 3 electrodes, anode, cathode and grid. So, grid basically control the number of electron moving from cathode to anodes. So, these vacuum tube, the diode was used in case of rectification and triode is used for amplifications. So, now feature of vacuum tubes. So, vacuum tube are voltage controlled device. These can operate at a high voltage, even it can work on a high power. Its power rating is high. According to the number of electrodes, a vacuum tube can be classified as a vacuum diode. I have already told you vacuum diode means 2 electrode, anode and cathode. Vacuum triode, that means 3 electrodes, grid, anode and cathodes. Next is tetrode. It has a 4 electrodes. If there are 5 electrodes, then it is called pentode. So, conventional tubes such as a triode, tetrode, pentode are useful only at a low microwave frequency. These tubes can't be operate at a high frequency due to their limitation at microwave frequencies. Now, high frequency limitation of a conventional tube. Why we cannot use this triode or diode for microwave frequencies? So, they are effective at low frequency, but when we use these vacuum tube at a microwaves, their performance deviate. If we use it as an amplifier, its gain reduce. If we use as oscillator, its efficiency is very poor. So, conventional tube become less effective at micro frequency when they are used as an amplifier or oscillator. The limitation of conventional tube at high frequency is due to following factors. The first factor is a inter-electrode capacitance effect. Second is lead inductance effect. Third one is transient time effect. These are the three factors so that are responsible for deteriorating a performance of vacuum tube at a microwave frequencies. So, first is inter-electrode capacitance effect. So, obvious name suggests, you see the name inter-electrode, that means between two electrode capacitance exists, because electrode are basically a metal piece, and between these two electrode is a gap, air gap. Air gap means dielectric materials, air act as a dielectric materials. So, a capacitance will exist between two electrodes. So, basically vacuum tube like a triode consists of three electrodes, anode, cathode and grid. A capacitance may exist between them. I will show you the slide here. So, see here, diode, in case of diode there are two electrodes, anode and cathodes. Both anode and cathode consist of metallic pieces, wire. So, between these two electrode is a vacuum air. So, that act as a capacitance. So, capacitance will inter-electrode capacitance will be CAK, anode to cathode capacitance. Again here in case of triode there are three electrodes, a capacitance inter-electrode capacitance exists between anode to cathode. Similarly, inter-electrode capacitance exists between anode to grid, and similarly inter-electrode capacitance exists between grid to cathode. Now, what are the effect of these capacitance on their performance at microwave frequency? Basically, the reactance of capacitance is inversely proportional to their frequency. When we are using these diode or triode vacuum tube at a low frequency, the reactance is nearly infinity. It play no role or in their operation of, it never present obstacle in the performance of the diode or a triode. But as the frequency increase, the microwave are very high frequency, and when we are using these type of tube at microwave frequency, so obvious reactance Xc will fall. As a result, a output can couple to the inputs. So, due to this feedback, the gain will reduce if we are using a triode as an amplifier at microwave frequency, because capacitance CAG is very small, anode to grid. We are applying input to grid and we are getting output at anode terminals. So, if reactance is very small, definitely the output will couple back to the input. As a result, the gain will fall. So, this inter-electrode capacitance reduce the gain of amplifier at a microwave frequency. That is why we can't use a microwave for microwave frequency, vacuum tube can't be used. So, next is lead inductance. We all know the vacuum tube has a metal terminals. When we apply a RF signal or a signal to these metallic wires, a current will flow, obvious magnetic field will exist there, and this magnetic field will cause a induced EMF into the wire. As a result, a EMF will induce here, and that EMF will oppose the cause which generated. So, this wire will offer some inductance, inductive reactance. So, a voltage will drop, some input voltage will drop across the lead at low frequency. So, this effect of inductance is very small, we all know the reactance of a inductance is given by relation XL is equal to 2 pi FL. So, as a frequency is low, inductance is very small, it voltage drop across terminal inductance is very